I don't know how to measure this. It's this thing here. Okay, so this is 30 centimeters here.
Hello. So if you've been in the drone industry, you might have come across the application for drones in measurements, specifically using drones to measure roofs or measure properties and all sorts of things in properties. And sure, you can't get millimeter level accuracy easily with drones, but for many use cases, having centimeter level accuracy or even higher is completely okay, and it all depends on the use case at the end of the day. So drones can be used for accurate measurement. So one of the things we wanted to do in this particular video is that we wanted to actually take one of our recent projects and essentially showcase it, where in this particular project, you had a warehouse that was being both measured and inspected. And just to show everyone not in the drone world, and just for giggles, we wanted to sort of see what if we measured the same property, not just using drones, but also using tape measure and see how easy or difficult it might be. Now, this was not done to survey grade, and we understand that tape measure probably isn't the best sort of alternative to drones. There are many other things that you can use to measure a particular property. But we just wanted to sort of showcase that the level of effort involved in using a traditional method versus using a drone, when the use case can actually do with centimeter level accuracy, is actually quite unbelievable. So, without any further ado, we'll go into this particular project and I'll walk you through everything from mission planning to capturing the data to processing to analyzing, measuring, reporting, all of that good stuff. So, do watch till the end if you want to get a sense for how the whole workflow works. Right, let's jump straight into it. Right, so what I've got on the screen at the moment is essentially the warehouse property that we wanted to both measure and inspect. I'm in Google Earth at the moment, so I took the coordinates of the property and I pushed them into Google Earth, and that way I can get the sort of first bird's eye view into the property. Obviously, the condition of the property is not accurate in terms of what you can see on Google Earth because Google Earth typically has outdated imagery. So, what we wanted to do in this project was to also inspect the particular property and also measure some of the solar panels here. The reason being, if there were more solar panels that had to be fit on this particular roof, if you are able to measure what the dimensions of the roof and the dimensions of the solar panel look like, you're able to actually have a pretty good estimate in terms of how many other solar panels could you fit on this roof and what might be some of the suitable locations. So, without any further ado, I'm going to move into actually doing the mission planning for this particular project. And then we're going to see the on-site workflow, both with drones and tape measure. And then we'll finally come back and process all the data. So I'll be using Hammer missions for this particular project. So with Hammer, I will be essentially doing the mission planning and then also the data analysis. So I'm going to jump into a project over here. So I'm in Hammer missions now. And so the first thing I would do in Hammer missions, I'd go into the mission planning. And once I'm in the mission planning interface, what I'd have to do is essentially set up a folder. So I've set up a folder here. Generally, you want to name the folder to the site name or the job name. And you want to keep things organized because over some time you have many different jobs and many different projects. You want to make sure that everything can be easily found later on. So I'm going to create a new file. I've already created a new file over here for the warehouse site. So I'm going to just jump into that particular file. And as you can see, so just using the coordinates again for the site, I can basically use this to move the map to the site. And now I've got the site in front of me with the particular property, the particular warehouse that we want to measure and inspect. So what do we do next? Well, the next thing to do is to create a flight plan for the particular site. So in this particular project, what we want to do is we want to capture the building completely. So we want to make sure we capture the roof and then we also capture the facade. So to be able to create a flight plan for this, we're going to go into our missions menu over here. And then we're going to choose either the mapping or the 3D modeling option. So both of the mapping and 3D modeling option can be viable options for capturing the roof. And if you have a particularly large roof, you might want to go for mapping to save time because you don't want to sort of have a crosshatch pattern. But in this particular project, we were able to actually, since we were using an M3E to capture the data, and since we had enough time to be able to do both the 3D model and the facade, we went for the 3D modeling option. So I'm going to pick that option, and then all I have to do is draw a polygon over the property. So just draw a polygon there, and then Hammer will create a default flight plan for me. So once I've done that, I can then essentially go and set up all the parameters of the flight. So I'm gonna basically be a bit generous with the boundary. So I'm gonna make the polygon cover more than the roof because you want to make sure you don't miss any corners. And Google Maps isn't super accurate in terms of where the building really is. So you want to make sure that you use a bit of a healthy margin to be able to understand the flight plan. So once you've drawn your polygon, you click on the settings gear and then you start configuring. So in fact, this one, let's say I'm doing it with a Mavic 2 Pro so that I can show you. So you can basically choose the camera you want to fly with. We're seeing a lot of flights being done with the Mavic 3 Enterprise now, so we would recommend that drone. But if you had a Mavic 2 Pro or a different drone to capture this, that's completely fine as well. You can just choose the camera you're flying with. So once you set up the camera, Hammer will automatically replan the flight. Now you've got to set up your altitude. So this is set to 164 feet by default. You could move this to let's make it a nice round figure. So let's say it's 170 feet. And Hammer will replan the flight based on 170 feet. Doesn't really change much because, yeah, the 6 feet is not going to make much of a difference here. Then we've got the ground offset. So the ground offset essentially is the height of the site or the structure. So in this particular case, that's the height of the roof. To be able to estimate that, what you can do is you can go back to your Google Earth. And once you're in Google Earth, what you need to do is essentially just go to the particular project. Let's say you go here, and you can basically measure. So you can click the measuring tool over here, and let's say you were to measure this way, that sort of gives you obviously the length. But what you really want to do is you want to measure the height. So I'm going to remove this and I'm going to just move it down so that you can get a height measure. So from this, looking at this, which is a very crude measure, you can see the height's about 10 meters. And so what you can do, let me just do another measurement just to be sure. So let's start here at the top and then let's go. Yeah, so it's about 10 meters. You can sort of see that's what the 10 to 12 meters is what the height is. So I'm just going to go back into Hammer and then I'm going to use, so 12 meters would be around 30 feet, bit more than 30 feet. So we're going to go for 30 feet over here as the ground offset. And that allows Hammer to essentially calculate the overlap for this project correctly. Then you've got to set up the front and side overlap. Anything from 70 to 80% or 70 to 90% is what we recommend. If you've got a really large project, you want to go towards 70%. If you've got a really small project, you can be more towards the 80 or 90%. In this case, we can sort of see that actually staying at 80% still allows us to do the mission in 2 batteries with 287 images, which is not too bad. So in fact, we'd want to keep it at 80%. But of course, if you had an even larger site and you wanted to reduce the flight time, you could actually go with 70%. And that just helps you optimize your time better. So there's a few variables to play around with over here, but essentially you're able to come up with something that gives you good results, but also efficiency. And there's always a trade-off between those two things. And then you've got your flight direction. So at the moment, the flight direction looks good. It sort of creates this sort of waffle-looking pattern on top of the roof, which is what you need. So you can leave the flight direction as is. I'm going to remember this as minus 112. But if just to show you, if you move the flight direction, Hammer will essentially plan with that direction. But what you want to do is just use the longest edge of the polygon and plan with that. So if you just click this button, Hammer will automatically bring the flight direction to the optimal one. So you don't really have to worry about it most of the times. Gimbal direction. So this is the direction of the drone's gimbal. You want it to face down, looking at the roof. So -90, essentially, that's what it does. It sort of allows you to use the drone to look down, and then the flight speed is automatically calculated for you. So it's 2 meters per second for this particular mission. If you wanted to fly faster, you can choose to do that, but you're going to miss images, and that's sort of a no-no because you want to make sure that your drone's camera is able to keep up with the drone's speed. So in some sense, if the drone is flying too fast and the camera can't keep up with all of the images that it needs to take in the interval between every two images, you're going to miss images. And so that's not a very nice thing because ultimately the goal here is to capture the best possible data. So let's leave the flight speed to what has been recommended in most cases. And then you've got the option to reverse the flight path. So we can sort of see this arrow over here on the top left. That means the flight will start from this corner of the polygon. But let's say you are inspecting this property from the parking lot, which is over here, in which case actually starting here is not a problem at all. But if you were for some reason inspecting it from here, so if the drone's pilot location is expected to be here, you might want to reverse the flight path, and that helps you see the mission has started closer to you and just gives you that sort of sense of confidence that you can see the drone, what it's doing as it starts the flight. You probably don't want to fly all the way to the end of the property and start the mission on the other end. It just from a safety perspective allows you to sort of have more control and gradually see the drone progress to the back of the property. All right, smooth corners should be on, so that essentially allows the drone to make these corners more evenly. So essentially fly a bit like a fixed wing and fly these rounded corners. That improves the efficiency of the flight, brings the flight time down, so you want to keep that on most of the times. And finally, you want to do a quick cross-check to make sure your images look good. So you'll sort of see this sort of a pattern when you turn on the show planned images. Each one of these blue dots is actually a dot where the drone will fly and take an image. So that's just something to keep in mind in terms of just cross-checking the pattern looks good and the images look good. You can turn them off. They're just sort of there for you to be able to quickly see what the pattern looks like. All right, so that's your mission plan for the roof. And what you want to do is you want to add the facade to it. But before I do that, I'll do a quick simulation to sanity check what that looks like. So I can see my mission plan both in 2D and 3D. So over here in 3D, I can see what my mission plan looks like and what the drone will do in flight. And that looks pretty good. I can even bring in the background layer if I want to just sort of see what it looks like in 3D. All right, well, that's all good. Now we're going to move towards the facade. So we're going to go back to our mission files, and then we're going to create a new file for the facade. So let's call this facade, and we're going to call this warehouse site. And once we've done that, what we want to do then is, before we open this file, we want to actually turn on mission layering. So we're going to go back to the folder, and then in that folder, we can turn on the layering option. And this layering option is really powerful because it allows you to see your roof flight plan with your facade flight plan, both on the same mapping layer. So I'm going to rename the initial file that we did. We're going to call that roof. This is just the file that we were working on, and that has the roof flight plan in it. Just to go back into it so that you can see, you've got your roof flight plan inside the roof, and then what you want to do is you want to do your flight plan for facade in a new file. So what I've got here now is a new file, and in this new file, what we see is that we've got a grayed out flight plan from the roof that I can still see so that I can understand what am I capturing, what does it look like, and I can use this as a guiding sort of layer to understand how I capture the facades. So now I want to capture the facades, and because it's a relatively short building, one of the things we want to be careful of when we do the facade capture is we don't really need to fly multiple different orbits around this building because it's such a short building. Typically, for such a short building, a 10-meter, 30-feet building, one ring around will be able to capture all of the facades. And so that's all you really need. So what I'm going to do is I'm going to go into the facade flight plan, and I'm going to choose facade mapping. So very important to choose facade mapping. Facade inspection is a legacy method in Hammer missions that used to be good for older drones, but most modern drones can work with the facade mapping mission. So if you choose the facade mapping mission, what you can do next is essentially you go and mark your facade. So you can essentially choose, so you just click on any point on the facade, another point on the facade, third point in the facade, and fourth point in the facade. You want to follow the geometry of the facade as closely as possible. And you also want to make sure that you use minimum number of points to create that boundary. You don't need to sort of mark every single change in the facade. So, for example, if there is a little bit of a ramp or a roof contraption over here, you don't need to follow it perfectly. You can just create a square because you want to have an approximation of the boundary and you don't want to have too many points because it might take too long to plan. Anyway, so we've created this sort of square with the polygon, and I press OK. And once I press OK, what's going to happen is that we've got essentially this particular facade pattern that gets generated, which is all of these blue dots, which are now looking into the facade and essentially allowing you to capture the facade. You will notice that this corner here is slightly empty. You do want to get images for this corner as well. And a simple way to sort of fix that corner is to essentially move this particular dot a bit further out so that more images are captured for that corner. So now you can see more images are captured for that corner. But if you really wanted to make sure that this particular corner is also captured perfectly, what you can do is you can move this to the left and you can add a new point from this plus button over here. So those of you who are very good with geometry will understand this intuitively, but you're just adding another corner to the facade. So that just allows you to do essentially that corner really well as well. And now you've got a flight plan that essentially is capturing the facades. And just like the roof, you can essentially go and configure that. So basically you click on the settings gear and then you've got the you choose the camera that you used before. So in this case, we used a Mavic 2 Pro, but a Mavic 3 Enterprise might be recommended at this stage. And you want to choose whether you want to fly width first or height first. So width first or height first, what that does is it just allows you to sort of specify, do you want the drone to go around the property first and then go to the next layer of the facade, or do you want it to go up and down as it goes along the property? Generally speaking, when you're dealing with a tall building, you might want to go up and down because you're covering the largest side of the building first. When you're dealing with a short building, you want to go width first. So you want to go around the property first. Top altitude, we've already determined that you've got 170 feet as the top altitude. And because it's such a short facade, we will keep the bottom altitude to 150 feet. So you don't need too many rings around the facade, if you like. One thing you will notice is that sometimes you have obstructions as you go and capture the facade. So there are a couple of ways to deal with this. One way is to increase the altitude of the flight beyond 170 and then add a gimbal angle of -45, let's say, so that you're flying slightly above the roof, but then looking down at the roof and you're avoiding obstructions. The other thing you could do is actually you can use something called obstacles in Hammer, and I'll get to that in a second. But basically, you set up your top and bottom altitudes. These can be adjusted on site. You set up your gimbal tilt, and then you set up the horizontal distance. So this is the distance to the facade. 33 feet is the default distance. If you wanted to go, let's say 66 feet, it will be slightly further away. Whether if you wanted to go 15 feet, it will be slightly closer in. What's really important here in terms of determining the good distance is to strike a good balance between GSD and your actual and distance to the facade. Most of the times you're going to have a really good GSD under 1 centimeter per pixel because you're so close to the facade. By the way, I have a whole bunch of videos on GSD and what that means and the quality of the data set. So I'm going to link some of those in the description below. But you want to set your horizontal distance mostly based on safety. Overlap. So overlap could be anywhere between 60 to 80%. If we go for 70% in this particular example, that's just going to replan our flight. That's going to show you a much more dense flight plan. And then the flight speed, you can leave it at 1 meter per second. I might actually move this to 60 because I think it might be an overkill to get that level of density for the facade over here, where this is not just a facade job, this is an entire building envelope job. Okay, so rotate points. So you'd want to keep this off because the points are facing the right direction. Sometimes the points generated in the wrong direction, where this option is really helpful for you to be able to flip that. Show planned images, that's fine. We can see the planned images. So what we're going to do is we're going to press the play button again, and that's going to help us see what the flight plan looks like. So if I quickly look at the flight plan, I can see it's doing 3 orbits around the structure. So it's going to essentially fly around the property 3 times to be able to capture it. So you can sort of see that here in 3D. And maybe that's good. Or maybe we want to do only 2 orbits because we don't see the points in going 3 orbits around with 3 batteries, where probably you can see everything in 1 orbit. So if it's 1 orbit, what you want to do is you go back to the settings, and you can keep the 3D option open if you prefer, and you can choose to increase your bottom altitude. So starting at 170 feet as your top altitude, and then if you reduce your bottom altitude to be pretty much the same, let's say 169, so 1 feet or 1 meter below, what that'll do is that it will generate only a single facade plan around the particular building, and that might be enough for this short building. And you will find buildings where you require multiple levels of facades around the building because of the height of the building, and this particular case you require only just the top, and just one particular ring around the building. So every project's a bit different. As you do more and more projects, you will get a hang of what's the right way to sort of capture it. But you've got all the tools here on your disposal. You can sort of see your flight plan. And with that, we are essentially done with our flight planning section. So once you've done these flight plans, they're obviously saved in your Hammer Hub cloud account. And once they are saved in your Hammer Hub cloud account, what you can do is essentially you can sync them with the Hammer app. So there's this button called Send to App. So if you click on that, it's going to give you options. And if you're using a DJI smart controller, you can essentially choose to download the DJI smart controller app for Hammer missions. And you can choose your favorite drone and or the drone that you have. And basically the drone that you have, you can essentially download the flight plan to that drone. So whether it's the Mavic 3 Enterprise, or if it's a Mini 3 Pro with the smart controller, or if it's one of these larger drones in the Mitri 300, which generally you don't need for the property side of things, you'll basically be able to actually download the flight plan on the drone, on the smart controller, and then the smart controller will essentially fly the drone to your specification, to the flight plan that you've just created. Before you go on site, though, it's always good to check the no-fly zones. So if you click on this button over here, and you can quickly check with the drone safety map. So if you click this button, it will bring up the drone safety map, and it will bring up that particular area for you to view. And once you view that area, it will show you if there are any flight restrictions. For example, this particular area here, if I click on that, there is a heliport that is in that particular area. So there is an increased risk for drone operations. So you want to be careful with this particular airspace. In fact, this is Class C airspace in this particular example. So you'd want to be careful about your drone flights. Inevitably, the local laws or the geographical laws for flights are different in every country, but this map just gives you a quick way to look at what is going on in that particular area before you undertake your flights. Right, okay. Now we are going to pass it on to Dan, who's going to be flying these missions on this particular property, and we're going to see you in the data analysis section. So see you there.
So this side has this protrusion here, so I cannot measure this side, but I can measure that one, which is over there. So no. We start here. Alright, so 30 meters. Okay, another 30 meters. Okay, so here is 30 meters again on this side. Okay, so it's here on 40, so 1 meter and 40.
Okay, so thank you for all of that flying and measuring, Dan. I can imagine it was not fun trying to measure that side of the building. So let's have a look at what the workflow would look like on the drone side of things and what the measurements turn out to be. So what we've done here is that we've gone to now the Hammer Missions data analysis tab. And in that data analysis tab, we have uploaded all of the images that were taken on site. So you can see all the thumbnails over here. These thumbnails are showing all the images from the drone. And you can also see actually all of these images as dots on top of Google Maps. And so what we want to do now is we want to take all of that data and we want to process that into a 2D map and a 3D model. So we will hit the process button here. So we click the process button and then we can choose a 2D map and a 3D model as the outcome. If you're using a thermal data set, you can essentially use the thermal processing option, but we don't really need that for this particular case at the moment. So we will choose the 2D map and 3D model option and we hit the process button. So I'm not going to do that at the moment because I have already pre-processed this project. So what I'm going to do is I'm going to actually swap to the 3D view and then also the 2D view, and then you'll be able to see, voila, we have the project that has been processed in 3D. So the first thing you can do is you can zoom around, pan around, and you can sort of see what the site looks like. And you get an updated view on the particular project, on the particular property, which, you know, is updated real time in the sense of shows the accurate condition of the property, as opposed to Google Maps, which is outdated. So already if you were to sort of take this and then compare it with Google Earth, you can sort of see that Google Earth doesn't even show all of the condition things that are going on. Let me get rid of this. It doesn't even show all of the new condition things on this property with respect to some of the structures that are on here. So if you go back, you can sort of see that there has the level of detail on each one of these structures on site is completely different when you compare it to Google Maps. And it's just much more updated. So that's the first big power that you get by using drone data as opposed to sort of satellite data from Google Maps, where you're able to actually see the site in its entirety. Now, Now that we have completely looked at the site, what we can do is we can actually, let's do some inspection first, yeah? So let's do some inspection and then we'll come to measurements to conclude the video. So inspections, well, there might be lots of different things you're interested on this particular roof. Maybe you want to sort of interrogate, let's say, some of the rust formation on this particular structure here. And there's just an example. What you can do is you can click on that particular structure. And then what Hammer will do is that it will bring up all of the images from where you're able to see that particular structure. So in the bottom over here, if I move myself to the right, you'll be able to see all these different parts, all these different images from where you can see that structure. So we can see it here, we can see it here, and we can actually annotate it. So we've annotated it as rust and corrosion. To do that, all you have to do is just draw a box, shift and draw a box over that particular area, leave a comment and press OK. So that's all you have to do. So I'm going to delete that for the moment, but you can sort of see how easy it is. We can also see it in other images. So if I just use my arrow keys here to sift through all the other images from where I can see this particular structure, and I can see also the from different vantage points. So maybe I'm interested in the bottom parts. Maybe I'm more interested in the top parts. All of that becomes quite easy to do when you've got different ways of looking at the structure. So yeah, so there should be one more image over here. You can zoom in and you can sort of pan around and see what that looks like. And as I've already mentioned, you can actually annotate. And because you've got both the facade images, you can sort of see underneath that structure, not just looking at it from a top-down point of view. And if there was any issue on the oblique side of it, you can also mark that up as an issue. So all of that gets saved in the platform. Right, okay. And what you can do is you can repeat the same process for many different parts of the site. So what I'm going to do is I'm going to actually click on the annotated images button over here. So before the video, I've already gone in and annotated parts of the site. And what that will do is it will bring up all of the images where you have issues. So I'm going to actually bring all of the image map and basically show you all the points where there are issues. So if we look at this particular image, so we're looking straight down here, that's showing that particular structure that we just inspected for rust, but there might be other structures. For example, over here, we are looking at potential water issue that is forming on this particular site, which can be seen very clearly from the images, essentially along the solar panels over here. And also, yeah, we've got lots of sort of unclean structures on site, and we can essentially mark all of that up. Maybe there are ramps on the project that are not compliant to the spec in terms of what they need to be. Maybe there are suspected water issues. Maybe there are cracks on the pavement. Maybe there are all sorts of issues. Maybe you've got rust and corrosion over here. And maybe you've got, again, cracks. Maybe you've got water puddles being formed. All these things can be detrimental to the property value and are things that you really want to know early on so you can do something about them, because the more you leave it, the worse it gets, you know. So stitching time saves 9 over here, basically. And drone data can give you all of that information quickly. So yeah, so you can go through all of that, all of those issues, and you can mark them up. And yeah, you might have all these issues like a stray pile or whatever, and you can quickly mark all of that up. Once you've done that, we will move to measurements. So we're gonna get rid of our image map and right click to get rid of the images. And what we're gonna do is we wanted to measure. So we would use our measuring tool. We're going to go back to meters for a second because this was measured in meters. So we're going to change from imperial back to meters. And we have this measuring tool over here. So what you have to do is just you use this tool, you select this tool, and then you choose one of the points here in the corner of the property, and you choose another point in the other corner of the property. And then what Hammer will do is that it will show you the length of that particular side. And what we can already see is that the measurement comes out to be 91 meters, 91.5 1.4 meters if you round it completely, which is really interesting because from the tape measure, we found it to be 91.44, as I recall, or something very similar. So we are essentially off by 0.4 centimeters, which is pretty interesting with respect to sort of how the how much accuracy you can actually get from drone data. And if the use case was to actually just essentially plan solar panels for the roof, that level of accuracy is more than enough. In fact, we can go to our 2D view and we can bring up our 2D map to showcase, and we can remove some of the images here. So let's get rid of the images. What we can see now is we've got a 2D representation of the same site. And if we wanted, we can essentially go in and measure our panels. So we can draw. So just to sort of show you how this all works with respect to measurements, we can just choose our measuring area option here. So we can choose the measuring area and we can measure whatever we like. So let's say we want to measure these solar panels. We just draw a polygon around the solar panels in our 2D view. So I'm going to go do this one here. And in fact, I might do them separately. So let me click the done button here and then adjust the polygon to align with the solar panels. And so once I do that, that gives me an idea for how many square meters of an area do these particular panels take. And if I wanted to sort of estimate what sort of what might be other areas where I want to put those panels, I can sort of have a look at the entire roof and then have candidate locations where we'd want to put those panels. Maybe we realize there's 142 square meters of panels over here, and so we can sort of create an annotation to track that in the platform. We can also then basically move that particular. We can use that to analyze. Maybe there is space to put a set of panels over there. In terms of putting panels, there's a whole sort of science to it. There's about shading areas that you've got to think about. You've got to think about positioning and all of that. So I wouldn't go into that at the moment, but the crux of it is that you can make your measurements easily, or your stakeholders and clients can make those measurements easily. And by the way, they can copy all these measurements just by clicking on them, and then they can move that into another reporting system or PV installation planning system. And that just makes it easy for anyone to be able to understand what are the next steps with respect to planning the solar panels on this roof. And in fact, you can also get dimensions for the entire roof. So if you wanted, you could actually just use one of these area options, and you can just draw a polygon over the entire roof that you can fine tune. And once you've done that, you can get the square meters off the roof. So let's just fine tune this a little bit more. Make sure we got our corners in the right places. And it's going to be an approximate, so it's not going to be 100% precise, but you'll get a rough idea. Okay, we've got sort of a 8,000 square meters in this particular 8,400 square meters in this particular roof, and that just gives you an idea. And you can delete any of these measurements and you can bring them back, and so it just makes it really easy. And one of the things you can also do is if you wanted to still look at the condition of any one of these structures, you just click on that particular part. I'm going to get rid of the delete mode first. You just click on any part of the structures, and what that will do is it will bring up. So let's say if I want to look at the solar panels and the conditions for these panels, I can just click on that, bring up the images, and then quickly have a look at the solar panels. And maybe I want to do an inspection on the panels as well, which is where some of the thermal both visual and thermal parts come in, and you're able to actually measure the efficiency of these panels with respect to their condition. So all in all, a lot of things that can be done here. And then finally, once you're done with all of your projects, you can use AI to actually look for some of these things, look for some of these issues, because none of this has to be just done manually. You can actually use AI-based tagging. So when you process the data, you can choose AI-based options to actually annotate and find issues in your data sets. That's something that is very much depending on the project, but common issues like cracks, rust, corrosion, spalls can be easily found. And if you're looking for something much more custom, that can be easily developed because drone data is just so easy to analyze for AI. So lots of potential here, lots of opportunity. And finally, what you can do is you can export all of the information of your project into a report. So you click on the report button, and then you can just choose to export all of the filtered images, all the annotated images. You can add an intro paragraph. You can add a cover image. You can add your own logo to the report. You can add the logo to every single page of the report. And you can also export the image tags and add guest links. And then when you hit generate report, Hammer will go ahead and create an example report for you. So let me just jump into the report quickly and show you what that looks like. Right, okay, so now we are looking at an example report which was generated by Hammer Missions, and this was done completely automatically, so you don't have to go in and create the reports yourself. It can be automatically exported from the platform. And so you can add your cover image of the property, you can add an introductory paragraph in terms of what was done in this project, and this can all be fed into Hammer. So if I go back to our project, and show you the view, you can add all that intro paragraph information here, all that good stuff, and then that gets exported here. And then the report shows you a summary, gives you a location where the particular site was located, how many images were taken, how many images were annotated, for instance, the issues that were found, the mild issues, the severe issues. There's a description of the issues and also any measurements that were taken. So, for example, over here, we took a measurement of the side, and also we took a measurement of some of the panels. And what you can also do is then you can sort of see a summary table for all the issues that were found in the project. And you've got a high severity table, and then you've got all of the other annotations that were basically created. And what you can do is, let's say if you wanted to figure out the suspected water issue, you can click on that link, and then it'll jump to that particular part of the report, and it will take you to that exact issue. And then if you wanted to see it in 3D, you can just click on this button over here, which will take you back to Hammer Hub, and it will take you exactly to that particular image, and it will take you to exactly that part of the project so that you can easily see where that particular issue is. So we're back into the project, and right now we have gone in through the link, and through the link we are now looking at the particular issue, and we can sort of see where that particular issue is, which is essentially somewhere around here. And so we can sort of see all of those issues in 3D, and so we can jump back and forth between the reports, which can be really powerful if you've got stakeholders, third-party stakeholders that want to essentially either conduct repairs or conduct any form of further investigation or forensics on this particular building. And yeah, you can essentially see all of the different issues that were annotated in the platform neatly laid out in the report. And obviously you can sift through that, and you can just give it all the annotations you need. And very soon you'll also be able to add a summary page to the report towards the end with your conclusions, recommendations. It's all going to be available in one place. So with that, we're going to conclude this video. I'm going to go back to Hammer Hub here, and I'm going to basically move back to a 3D model. And yeah, I will just urge you to think about how easy it was to actually use a drone to measure this building, to inspect this building. You didn't need to get someone on the roof to do the inspection. You didn't need to get tape measure and struggle with tape or other measures on site. And once this information was available, you can disseminate this information to all of the different stakeholders that are involved in the projects, whether it's the contractor, whether it's the engineer, whether it's the architect, whether it's the repairman. You've just got so much more power that you can leverage with drone data. So I urge you, if you aren't using drones already, to explore using drones. And if you are using drones and not using this workflow, do explore this workflow. If you've got any questions for us, do get in touch with us. We are Hammer Missions, so we essentially provide the software solution to be able to power all of these workflows. And we also create a lot of this sort of content online to sort of walk you through workflows. Do check out some of our other videos on, if you want to, how do you capture facades and towers and all sorts of interesting structures. And if you like our channel, do give us a subscribe. If you have any recommendations for what videos we should cover next, do leave them in the comments box below. I will guarantee you we will look at that and then plan our next few videos. Thanks so much for watching. We'll see you in the next video for Knowledge Hub.